Hi, I'm DJ Ware. Today what we want to talk about, I don't want to deal with any more drama. So I'm going to go back to the software stack of things that you might find interesting and things that we might want to use in our everyday lives. So this is about GnuPG, which is the GNU Privacy Guard. And this is it's a presentation and a tutorial. We're going to go through on how to use it. The first thing is this quote. I love this quote. I don't know who said this, but it's a good one. So I have 6 door locks on my door at all in a row. So right down the door frame like this. And when I go out, I lock every other one. So no matter how long someone stands there trying to pick the lock, they're always locking 3. The GnuPG is a tool that is in the open source library. It is licensed under the GPL. I think it's version 3 actually that it's licensed under. It provides 3 different capabilities. The first one is it allows you to create and manage encryption keys. But not only does it allow you to create and manage those keys, it also allows you to perform encryption and decryption tests. And finally, it offers a mechanism by which you can digitally sign a message, and then someone who has a copy of your signature can verify that that was you that produced that message and is not someone else masquerading as you. The 3 different use cases that are available, there's probably more, but these are 3 of the main ones. So, of course, encrypting and decrypting files, we're going to cover that one. We're going to cover digital signatures, both the signing and the verification of those. I'm not going to try to go after encryption and decrypting of emails. That gets into configuring your email client. There are so many different ones. They all act differently. I would, if you're interested in that, the GnuPG has documentation for a lot of the major ones that'll help you set up your email in order to do that. If you're installing GnuPG for the first time, where can you install it? Well, there are copies of GnuPG that's available for Windows. Also, it will work on Mac and Linux and Android. If there is not one for iOS, but if you do want one, there is one called PG Pro, and that's based on the OpenPGP standard, and so you can use that. By the way, those are compatible with each other. So I can talk about it and confuse you, or we can just take a look at a tutorial, and I'll go through the 3 things that I said I was going to accomplish today. So let's take a look. I have a directory that I set up here for this, so let's go through some basics on the commands. So first of all, the command is called GPG, and I'll probably mistype it about 100 times during this demo. But if you want to know all of the command functions, you can do a help, and you can see it's quite extensive. There's quite a few things you can do with it. And you can also, there's a man page for it as well, which will give you, some information, what it's interoperable with and all that stuff. The most basic of the commands is to list what keys you have. Well, I don't have any, so we're a blank slate. You will be too. So, yeah. Also, that lists your public keys. And if you want to list your private keys, instead of private, they say secret. And I don't have a secret key either. This implies that what this generates is GnuPG will handle both symmetrical and asymmetrical keys. I'm going to talk about those when we get to it, because for right now, we'll just keep things general and then we'll dig down into things as we go, rather than try to hit you with it all at once and then lose you. So I want to generate a key for the first time. Now, by default, this is going to generate a asymmetrical key. That means that I'm going to generate a public key and a private key. So it's going to ask me some questions here. All right, so I'm going to give it a name. I'm going to give it That is a valid email address, but it isn't mine. But the thing is, as we go through this, there are some things that I'm not going to be able to show you. All right, so it wants me to protect. Now, this is protecting my private key. The pass key on async doesn't get sent with the public keys, so this is only protecting the private key. Okay, so now it says it did the public and secret keys created and they were signed. So I can then go back up here and list. There's my public key, which we already saw. And there's my private key. Now that part, that private key, you don't want to share that with anybody. You don't want to give that to anybody at all. What if I want to export this? I want to save it so that if I'm moving this over to a new system, I can take this key with me and use it over there as well. So you'll need to know this. This is the ID of the key. And it's the same for the public and the private key. So we'll need to copy that. And then we'll do a PGP export. Let's do the secret key. And armor means you have two choices in the output file that it generates. It can be a binary file or it can be a text file. This dates back to the old days of email on the internet that did not handle binary messages at all. We didn't have a means to, we had a means to send pictures, but you had to convert it to ASCII first. So unfortunately, that's a long dead practice, and you don't have to do that anymore. So what I want to do is I want to give it the key ID now. Now, if I just let this go, it's gonna send that right to my terminal, and in binary form, it probably will create the biggest mess on my screen ever. So this is my private. I just do it that way, and we'll make it ASCII because it is ASCII. That's why I wanted to use this as ASCII anyway. Now it's asking me for the passphrase. And it's done. So I can do a listing on this. I've now exported my private key. If I want to produce the output in binary, let's change this over. And then we'll go and remove the armor. So you'll notice that this top one is just the private key block, which is that. And then this one down here is a binary file that's compatible with the OpenPGP certificate. So what about deleting the key? Oops, sorry about that. You have to start with the secret key first. And we have to give it this ID again, which I should have in my buffer still. I do. Okay, so it's going to say, you're deleting the key from the key ring. Are you sure you want to do that? And now it's going to say, are you sure? Are you really sure you want to do that? And now it's saying, come on, you are really got to be sure because, yeah, are you really, really sure? And then finally it deletes it. So now my private key is gone. If I do a list on the secret key, it's gone. If I do a list on the public key, it's still there. So now I got to get rid of this one. And to do that, it's very similar. Are you sure you want to do that? Now this one doesn't care too much about, so it only asks you once if you want to delete it. But as you'll see, now they're all gone. So I'm right back to where I started. Why did I do that? Because I wanted to show you how to do an import. Let's bring in the ASCII. And there's my passphrase again. This is the one you created it initially with. And you'll notice it says, I got one number processed, I imported it, one secret, and imported it. What does that mean? It means that it imported my public key and my private key. So they should all be back, unless we have a bug. So there's my private key, that's back. And there's my public. So that's how you move it from one system to another. So there's also another way to do this too. I'll just show you the command. I'm not going to do this, and the reason why I'm not going to do this is because just like everything else on the internet, they've probably been bombarded by requests. This is a real key server. This is PGP MIT.edu. There's a number of them. And I would just do a send keys, and then I would put in my ID and then send it. The problem with this is that they've had to validate that. So they send an email out to this address and say, is this you? And if you answer yes, then they'll store your key. If not, I assume they wait a certain number for a certain amount of time, and then they delete it. Once you have it up there, you can tell people that you want to communicate with how to download your public key, because that's only going to send your public key. That's not going to send your private key. It only uploads your public key. So you can just tell them, here, this is the information, this is the email address that you can use to receive it, and they're able to get that. So if I do and then I would put in that key path again. I'm not going to send it because it isn't there and it won't find it. There's two types. We kind of talked about this a little bit, but there's two types of encryption that PGP handles. It's symmetrical and asymmetrical. I've kind of talked about this in the past, but GnuPG supports both methods. So basically, a symmetrical key, you lock it down with a passkey, and then anyone that has the passkey can decrypt it. So you could, if you're dealing with a group of people that need to have access, but you don't want to encrypt the file as it goes over the internet, you can encrypt it with a group with a symmetrical key, hand that passkey out to the group that needs it, and then they can decrypt the file and see what the contents are. The other way is asymmetrical. That one is designed more for talking to individuals. So you are wanting to communicate one-on-one with somebody. So let's talk about the symmetrical before we delve into the asymmetrical. So the first thing is, how do I know what encryption versions I have available to me? Well, if I type in version, it also gives you the same message on help, but there's also all this other trash that comes with it. So you'll notice that we have pub key, cipher, and hash, and compression. So pub key, these methods are algorithms for encryption that are used in asymmetrical keys. So you have RSA, ELG, DSA, da-da-da-da-da. The ciphers are used in symmetrical, and those are 3DES, CAS, Blowfish, AES, AES 192, AES 256. By the way, these are equivalent. AES and AES 256 is equivalent. You may go, oh, 256 bytes, that's not enough. Well, the AES it is. AES is a very strong encryption protocol. Yeah, that's all it needs. And you've got, the life of the universe to be able to break the thing. These hash codes you probably have seen before. These are used to verify files. So if you get an ISO file for a Linux distribution, you probably have noticed there's a hash key there. Well, that's where it came from. There's a number of ways they can do it. They can also do a verification with the GPG. So, but SHA-1, don't use it. SHA-1's been broken. Don't bother with that. That's too easy to replicate. SHA-256 wouldn't recommend. anything above 256 is fine for right now. But yeah, SHA-1, SHA-256, don't use. But those are usually used to identify that if I'm a developer and I produce an ISO file and I put it on a server, I can run the hash and get the hash for the file that I saved, and then I can tell you what it is so that when you download it, if it isn't the same, you know it's been modified. What of those are best? Anything but DSA. Don't use DSA. Yeah, that's another one that's old. How do I use symmetrical? So if I want to encrypt a file, so there's my super secret file, and what I want to do is encrypt that. So all I have to do is tell it I want symmetric and then what file I want to encrypt. Of course, I have to spell it right, otherwise it will not get it. And then it's going to say, okay, give me a passphrase. So this is the passphrase you'll give out to decrypt the file. So there we go. So it should appear out here as a binary encryption. And you'll see it there. Yeah, don't list it. It is a symmetrically encrypted data. Tells you it used the AES cipher. So I can do I guess I better tell it what I want it to do. I want hex and I want character. You can also do it in octal if you want, but I bet most of you don't know octal. But anyway, so this line up here is the ASCII, is the hexadecimal, and this is the actual characters. So you can see some of those are obviously going to be interpreted by the terminal as commands. It's encrypted, and now I can send that file off. As a binary, it will work fine today. However, if you do want to send it as ASCII, you can do that as well. So all you have to do is preface it with armor. Put your key back in, whatever it is that you're telling people to use. And this time we have ASC. And I can bring this up. This is just a text block. So that's AES encryption. It's very short and doesn't take long. The harder the encryption strength, or the larger it is, the larger the file becomes. So what about asymmetrical? So again, same thing. You can get the list of the versions here, and you can pick from those. Default is RSA. Asymmetrical is designed to be one-to-one. So, in other words, if I want to communicate with you, and I want to be able to encrypt a message, and I want to give you a way to decrypt it. Conversely, you'll want to respond back to me at some point. So you may want to encrypt a message, and then I'll have to have some mechanism to decrypt it again. So in asymmetrical, you have the public and the private key. The public key is used to decrypt a message. The only way you can encrypt a message is I have to use let's say I want to send you a message that's encrypted. I have to use my private key. And because I'm using my private key, I have to give you my public key to decrypt it. Because if you don't have that, you don't have any way to decrypt it. Conversely, when you send me a message back, you would use your private key, and I would need to have your public key in order to decrypt it so that I can read it. Simple as that. I've shown you how to actually create, because we did it. We actually have a public and private key already. So this is the one, this public key that's listed pub, that's the one I would want to send so that you could use it. So I would then, I would send my request off and do a search on the email address for that person, if that's the one. I don't think these are up right now. I think they're down for maintenance, and then once I get it, I can then do a PGP, and that should show me that I have the information I need. But I can't show it to you right now. You'll just have to trust me. How do I encrypt that message? So I have this message out here, right? I'm going to get rid of okay, I got rid of all those. And I'll get rid of that one too. So, all right, so I want to encrypt and then the user ID is going to go to me. Yep. And that's it. That's all I want. So I could send it to multiple people, basically. Okay, so there's the message in binary. Same thing here. You can, if you don't want to type in all of this stuff, you can do the ask if I want to overwrite it. So now that message is ready to go to them. If I want to, I can also put it in ASCII. And there's my text. You notice it's longer because it's using RSA. What if you received an encrypted message? What if I've got this file, right? I've got this file right here that's encrypted, and there's no way I can read that. So let's say that I want to decrypt it. I'm going to be using and there's my data. You can use the -D, that's short for decrypt. Again, that's going to go to the terminal, and just like all things, you can redirect. And there's my message. The last topic has to do with identifying that the message came from you and only you. So basically, that's a form of non-repudiation. You may hear that term, you may not, but non-repudiation is a protection mechanism that's used to, when a person denies that they did something, there are security mechanisms that can prove that they did. So it's really meant to, it's sort of a negative thing, but actually it is really meant to prove that the message came from you and could have only come from you, because it was you that generated the signature file from your key. So how do we do that? So I guess that's the first thing we need to do. Each message that comes down like that GPG there has a signature in it. It's included with it. You probably noticed that when we encrypted it, it said, okay, we're encrypting and signing. So if I want to break that out, that signature out, because I want to use that in the future, then I can do that. And it should have created a SIG. and that's going to be in binary. You notice I didn't have to tell it where the encrypted message was. So now I have a signature. So anytime now that I get something from somebody, so the last piece that we want to do is we want to be able to validate that that message came from you and only could have come from you. That is a form of what we call non-repudiation. We're using this non-repudiation as a protection mechanism. So the signature is the protection mechanism that helps identify that that message could have only come from you. So when we're talking about signatures, this is typically the scenario. You would encrypt the message and then sign it. That would be the manual process, but GnuPG does all of that for you automatically. So every time you encrypt using your private key, it automatically creates the signature to go along with it. So how do we get that signature out? So we're going to detach the signature and we're going to get it out of the encrypted version of message.txt. Now, of course, it's going to ask me for the private key passcode. And there we are. So it'll create a file called .sig, and that we can look at, and it'll tell us that is a signature. The next step is I can validate that signature file, and we can do that by, and it'll look at it and say, that looks valid. However, we don't have the second piece of it, which is how that someone has verified or certified that that is me. But it will work, and we can then go to the next step. In fact, why don't I just pull that back up? And this time we'll validate the message with that signature. Okay, so it says signature is good, signature and the message is good, but you got a problem, it's not certified. But that's how you would then validate a incoming message that the signature is right. Now, I'm not going to go through how to certify the signature. That's kind of beyond what I want to do today. So that's where I'm going to kind of leave things for today. With that, I think what I would like to do is to once again thank my Patreons and also my Patreon members and also members of the channel. Thank you so much for your support, and for those of you again who watched this video to the end, thank you so much for your support as well. I hope to see you all in the next one, and I hope you enjoyed this video. If you did, please like and subscribe. Bye for now.